remember this one, it was a doozy.
All right, we're gonna review section 7.7 through 7.9 for your viewing pleasure, but we're gonna go to 7.7 number 36, and this is Cauchy's mean value theorem. And what Cauchy's mean value theorem says, basically we've got two functions, so this is a theorem, so I call it, instead of MBT for mean value theorem, it's CMBT, Cauchy's mean value theorem. And f and g are two functions, and they are continuous on the closed interval in your pen, differentiable on the open interval. And we also know that the denominator is not equal to 0 on the open interval. So g prime at x is not equal to 0 on the open interval a to b. Then what we can say is there exists a point strictly in between a and b, such that what? Such that f of b minus f of a, so f evaluated at the endpoints divided by g evaluated at the endpoint, the difference of g evaluated at the endpoints is going to equal f prime at c over g prime at c. But what did we say? We know that g prime doesn't equal 0 anywhere on that open interval. So anyway, and then we're going to find the c. Now they use a z in the book. No big deal. We always use a c, right? So we were going to do this. So it didn't really matter each way. So that's the theorem. So continuity on the closed interval, differentiability on the open interval. We had that a lot in Calc 1, right? And then basically this is similar to numerator over denominator of the mean value theorem is really what it was. So then we want to use Cauchy's mean value theorem on number 36, which is what? Function. We had two functions on 36. One was
X ln x plus 1.
f of x is the natural log of quantity x plus 1, and g of x is the natural log of x, and the interval is what?
1 to 2.
1 to 2, so this is A, this is B, right? First of all, are these continuous functions on the closed interval? How do you know? Do we know what this looks like? Well, let's do this one. This is a base, kind of a base graph, right? But natural log, this looks like that, and it cuts through at 1, it explodes down to negative infinity. The domain of this is not including 0 to infinity, so positive reals, right? And this one is what type of shift? It's a left shift, because what do you plug in to get 0? Natural log of 0 wouldn't exist, right? You plug in negative 1. So it's a left shift here. And it actually, if you plug in 0, we get the natural log of 1, which is 0, right? So we have this. So these are definitely both continuous to the right of 0 for this one and to the right of negative 1 for this one. Draw them without lifting your pen, right? So we don't have to go into more formal proof. Anyway, so, and are they differentiable? Well, if you're not sure, take the derivative. Differentiable means just take the derivative. What's f prime? 1 over x plus 1, and g prime is 1 over x, right? Derivative of natural log is 1 over. That thing times derivative of what's inside. Derivative of what's inside here is just 1, right? So chain rule doesn't really change that answer. Anyway, this is fine to the right of 0. So certainly on the open interval 1 to 2, we're fine. We're differentiable as well because you can take the derivative. So I've satisfied 1 and 2. Therefore, what? Therefore, there exists a point strictly in between 1 and 2, such that what? F of b, what's f of b? So f of 2 minus f of 1 all over g of 2 minus g of 1 equals f prime at c over g prime at c. Okay, now this is what a lot of people mess up. The left side is just f evaluated at that. It's just the function, f and g. It's not the derivative. So it's these. right here. Okay, so what's this become then? So this implies f of 2 is the natural log of 3, right?
Yep.
Because you plug in 2 there. So this is natural log of 3 minus natural log of 2 over g is natural log of 2 minus natural log of 1. Of course, what is natural log of 1? 0, right? So this goes to 0, so I can rewrite this. And I guess for me, this left side, a little easier if I just rewrite that as, how could I rewrite this difference of the natural logs? Natural log of 3/2. So this is natural log of 3/2. You don't have to do that. I did because it makes that a little bit easier. So that's the left side there is the natural log of 3/2 divided by the natural log of 2. All good with that? And then the right side, we've got f prime at c over g prime at c. Well, f prime is right here. So f prime at c is 1 over c plus 1, right? And then g prime at c is just 1 over c. That's what that one equals, right? So how do I simplify that? Flip them. So it's instead of dividing by 1 over c multiplied by c. So this part equals c over c plus 1, right? And then it's just a matter of setting these two things equal to each other, right? So let's do that and solve. Okay, so I always prefer exact answers when possible. So I've got c over c plus 1 equals natural log of 3/2 over natural log of 2. This is a ratio, which is compares to two things. It's actually a proportion, right? Because I got two ratios that are equal. What do we know? Cross products are equal, right? So I can say c natural log 2 equals c plus 1 times natural log of 3/2. And the natural log of 3/2 is just some number, right? So what can I do? I want to get all my c's to one side, everything else to the other. So just multiply it through, right? So just a little algebraic thing. So I got c natural log 3/2 plus natural log of 3/2 times 1 is just natural log of 3/2, right? And this equals c natural log of 2. So I'm going to get this to the other side, right? And so I'll have c natural log of 2 minus c natural log of 3/2, everybody agree, equals the natural log of 3/2, which is what's left on the right. I mean, what's remaining on the right. Okay, all good? And what can I do here to solve for c?
Take a C out.
Factor it out. So it's c natural log of 2 minus natural log of 3/2 equals natural log of 3/2. Now we can, and then to solve for c, you just divide both sides by that, right? So c equals natural log of 3/2 divided by natural log of 2 minus natural log of 3/2. Now this may or may not be the easiest way. So there's a lot of different ways to write this. But once again, the denominator, we're subtracting natural log of two things. So how can I rewrite that? Natural log of first one divided by the second one, right? So divided by 3/2. 2 divided by 3/2 is what? Yeah, divide, flip and multiply. So this is natural log of 4/3. So the best answer is natural log of 3/2 divided by natural log of 4/3. If you'd rather rewrite it as, so let's just go to the answer here. So the answer for C, natural log of, what did we say, 3/2 divided by the natural log of 4/3, or natural log of 3 minus natural log of 2 over natural log of 4 minus natural log of 3. Does that simplify it all? Not really. There is a numerical answer. Both of these are about 1.4094, depending on about 1.41, depending on how far you want to take it out. Okay. But what I was saying, if you remember, what I was saying is if you can get it to an approximate numerical value, you can hopefully solve exact as well, which in this case we could. Just gotta use some algebra. All right, but that's Cauchy's mean value theorem. All right, any questions on that? The only thing really awkward there was just trying to manipulate and solve for C. That was just algebra thing. Okay, so there you go. Cauchy's MVT. Awkwardly, I can't stop recording.
So,
Still can't stop recording.